All right, now we are going to get into one of my favorite sections and one of the probably the most intense sections of the course, and that's on quadratic functions. This is where we leave the nice simple world of lines and linear functions and get into quadratic functions, because we know that most things do not behave in a linear fashion. And there are a lot of things that behave in a quadratic manner. In particular, those of you in physics know that if you throw a ball up in the air, its position is going to be a quadratic function of time. And we'll be looking at that example and other examples in the next section. Right now I want to focus on just the nature of quadratic functions and what their graphs look like. So, in short, quadratic functions are functions whose graphs are parabolas. And that is that if we look at an equation like the one we have here, we can obtain it from the basic function y equals x squared. You can see. If we have y equals x squared, we can replace x with x minus 1. That's going to be a shift to the right, 1 unit. And then if we multiply this whole expression by 2, that's going to be a vertical stretch. And then finally, if we subtract 3 from the whole thing, that's going to be a shift down 3 units. Okay, so if we want to see what the graph looks like, okay, obviously here is the graph of y equals x squared. Okay, if we shift to the right 1 unit, we get this. And if we shift to the, or if we multiply this by 2, so this is going to be a vertical stretch. And then we're going to shift this down 3 units. So the final graph will look like this. This point is now down 3 units. It's right here at the point 1, -3. And you can check that the y-intercept is going to be, when you plug in x equals 0, you get 2 minus 3. That is minus 1. So it goes through this point just to help us out. And so our graph is going to look like this. Okay. And here's our point 1, -3. Okay. And of course this is going to be what we call the vertex of this. So that's why we are doing this system of substitutions. We get another parabola. And in this way, we can also get an idea of what the x-intercept would be. That we can see that we have 2 x-intercepts. And we can see, to find out what this is, it's not too bad. You set y equals 0, and you get 2 times x minus 1 squared minus 3. Oops, let's see if we can see that there. And we can take the 3 to the other side. Okay, and then divide by 2. Okay, and we don't have to multiply this out, do we? Because if we know what x minus 1 is, that's almost as good as knowing what x is. So we can take the square root of both sides and then add 1 to both sides. And we get that x is going to be 1 plus or minus the square root of 3/2. Okay, whatever that is. Okay, it's going to turn out that one of these numbers will be positive, one will be negative. So that's what these 2 values are. Okay. The other thing I want to show you is that this even though we did all of this without multiplying it out, we could still multiply out the equation and write y equals 2 times x squared minus 2x plus 1 minus 3, and this would be 2x squared minus 4x, and then we have plus 2 minus 3. That would be minus 1. Okay. All right, and so we can still multiply this out, and we get something times x squared plus something times x plus a constant. And that's ultimately what our definition of a quadratic function will be. Okay. Now what I would like to do, another example, where we start with an expression like this, and go back and put it in a form like this, up here. So that's example number 2, and we've already started that. And in this case, we're using our completing the square method. Okay. You may or may not see this on the homework, but right now but I want you to just sit back and enjoy the ride here and see what the steps are. So we have we have an equation where we have y equals 3x squared minus 8x plus 2. And we'd like to see what does the graph look like without doing a whole bunch of plotting points or using our graphing calculator. Well, it's going to turn out that we can put it in the previous form by completing the square. We first factor out the 3, and that's where we have an 8/3 and a 2/3 here. And then we have this thing about completing the square. Okay, we remember how to complete the square. We look at the coefficient of the, well, we first make sure that we factor out the 3 here. And then we look at the coefficient of the x. It's negative 8/3. We can divide that by 2, and we get 4/3, and then we square 4/3. And so we're going to be adding and subtracting 4/3 to this expression. So we don't change the expression. And then, so that's how we got this. We got negative 8/3 divided by 2, and we squared it. And this turned out to be negative 4/3. Okay, which of course is the same thing as 4/3. Okay. All right, so then if we take these 3 terms, this becomes x minus 4/3 quantity squared. This is negative 16/9, and this is 2/3. We can now distribute the 3 here. 3 times this is this, and then 3 times 16/9 is 16/3, and then 3 times 2/3 is 2. And then this fraction is 16/3 plus 6/3. Well, that's going to be negative 10/3. Okay, so that's what we have here. And we can see that we have exactly something in the form of what we had before. We have something in the form of a times x minus h squared plus k equals y. Okay. And we'll see here that in this case our a we could do the whole system of transformations. Again, replace x with, we start with x squared, replace x with x minus 4/3, and then multiply by 3, and then subtract 10/3. So again, we'll have a shift, stretch, and then another shift down, and what we get is we have this another parabola where our vertex is going to be at 4/3, negative 10/3. And then it turns out our graph will look like something like this. Okay, we can double check that the x-intercepts are precisely that will both be positive. The same we did before. We can, if we want to find the x-intercept, we can set y equals 0 and get 3x minus 4/3 squared minus 10/3. Okay, and then just go ahead as we did before, and you can check that x is going to be 4/3 minus the square root of 10/9, and 4/3 plus the square root of 10/9. Okay, right. So now we won't necessarily have to complete the square for all examples and all the homework problems you're going to be doing. But I just do this just to show that there's this connection here. Okay, that in fact any equation of this form will actually be a parabola.